Okay, I think we have one person, and I'm really glad for you guys to be here. I go with Naruto as my anime name. It's just an anime that I loved. But today we're going to be talking about Avail 101, what Avail is, and what you're basically building, or what you can hit on bounties. So what to expect during this workshop. We're going to go through Avail, Trinity, AvailD, Nexus Fusion. There are three different products, and then from there, we're also going to deep dive into the architecture of Avail, and then some examples of what you can build with. So first of all, what is a DA layer? So everyone keeps on asking what's a DA layer, what they can do with it. Generally, Ethereum or any monolithic chain, they're divided into 4 layers with different tasks. So you have execution, settlement, consensus, and DA, which is the data availability. DA is basically where nodes can look at the data, and it's contained within all the blocks propagated through P2P network. The basic idea is that you want the data to be available all times, and then people can link through the nodes and look what there is, right? So nothing very super, complex. A data availability layer is basically where you post all the data, and then you make sure that data is available at all times. Big picture. So Ethereum has so many rollups. It's a L2 landscape, and at this point, there are more than I think 100 rollups coming in. And that's what we want to do. Because of all these things, you want to have these DA layers where these rollups can post data, because dank sharding or the 4844 is way too ahead. Full dank sharding, 4844 is right there. What DA solutions do is that AvailD is powered by erasure coding. KZG will go through all of these things, what they really mean, how you can actually do stuff with these, and then what is the fragmentation of liquidity and UX that you keep on seeing with L2s. I'll go with all the details, but this is the basic big picture on what we're trying to achieve here. We have a DA layer, and then from there we have Avail Nexus, which is what unifies the L2 or Web3 ecosystem, and then we have Avail Fusion for macroeconomic security. Avail unification layer. So these are 3 products: AvailD, Avail Nexus, and Avail Fusion. What is AvailD? AvailD is basically a very powerful validity proof-based DA. What it basically means is that you have blob space that can help scale through the light clients, and then DAS or data availability sampling. There's an easy verifiability through KZG commitments. We'll also go through KZG, what they are, and when they came out to be. That was 2010. But AvailD is on mainnet now. So we went mainnet three months back, and there's also a testnet that you can play with. Then there is Avail Nexus. So Nexus is pretty interesting. It's a permissionless verification hub. What basically it means is that think of a ZK coordination rollup where you have to do a lot of cross transactions, but you're trying to curb the fragmentation that happens through liquidity. So it uses proof aggregation. Proof aggregation is basically you generate multiple proofs for different rollups. So as you can see in the diagram, you have let's say rollup 1, 2, 3, 999, whatever, right? And all of these basically generate a proof, and then this proof is aggregated, and all these proofs get submitted by one single proof. So there's a lot of proofs happening, and then a single aggregated proof is what generates it. And then we use AvailDA, data availability layer, as a root of trust for everything here. It also has a sequencer selection, so all the transaction sequencing and inclusion is coordinated via the decentralized sequencer. So that's a different mechanism, and we're working on that. We're targeting end of 2024 for this, but right now we're going to focus on AvailDA because that's where your bounties lie. And then finally, Avail Fusion. It's a shared security layer. As I previously mentioned, that we also want to look into cryptoeconomic security of the ecosystem. So because of that, we are building Avail Fusion. Big thing about this is that it can also take multi-assets from different ecosystems like Bitcoin, ETH, for the additional security. So that's what it does, and it contributes to the consensus mechanism overall. I'll skip this, and then AvailD. Okay. So as you can see, AvailD is a modular base layer. What it does is that it gives you the block space to the modular chains. You can think of it as a sequencing, packaging, and publishing data, and then it can segregate text transaction data or like for any rollup, right? So AvailD will have a lot of like validator set, and it uses something called nominated proof of stake for the consensus mechanism, where we'll go forward later on for this. And then finally, like each rollup, it can be built on AvailD for any kind of like custom things as well. So you can have app-specific state machines. You can change multiple things in your rollup that you deploy on Arbitrum stack, OP stack, or zk-sync chains. Any questions so far? Good. Okay, so AvailD Lite clients leverages KZG commitments. What KZG commitments basically mean, I'm gonna just go forward for a second, but KZG commitments are something that commits to the values of like, anything in a succinct manner. You generate very small proofs, which makes it easier for Lite clients to verify the availability. So think of this way, you have nodes, you have a different validator network of nodes, and then you have a Lite client. These Lite clients are very much capable of, instead of like just downloading the whole node, they can verify it without downloading the whole node or like whatever there is. So the idea, very small idea, is that there's a validated proof. It can be generated, computationally efficient to prove and verify the data is actually available and live. So that this means that you don't, as a dev or as a user, you don't need to like download the whole block space that was probably there since like 3 months, a year, or 2 years long. You can just verify through the Lite clients. Going back, we also use eraser coding and data availability sampling. So this allows, as I said previously, it allows the verification without downloading the whole block data. So there's a multiple things that happens in the back. And then this is the whole thing that allows for you to build anything on top of AvailDA, because you have Validiums, L3s, Optimums. You can use anything to build these things. And at the same time, there can be shared security because we have Avail Fusion, and then applications, they do not need to have their own validator set. There's a validator set that we have. So in very general terms, you have KZG commitments, you have erasure coding, and then you have data availability sampling. I went through the KZG commitments. What erasure coding is that it's basically a method for protecting your data. And then it has been used for CDs to protect the data. And what it generally does is that it adds the redundancy to the data and separate them into the chunks. As you can see in this whole diagram, that you have a data and then it gets, divided into multiple chunks. And then finally, you have data availability sampling. DAS is a very big thing that has been used by multiple projects. And what it does is that it leverages Lite clients, validated proof, and erasure coding to randomly sample data from Avail blockchain. And the bigger thing is that you can get 8 to 30 samples for the the random checking or the guarantees of the data. Okay, this is the architecture. It doesn't have, just for theoretical knowledge, it won't be for the bounties, but it's a good thing to know that how it generally happens is that you have an original data, you have an extended data that is generated with the erasure coding, and it generates a Avail header or a block, and that's the KZG commitments. Now, this KZG commitments is later on constructed as a block. You have a block which has a header and then data, plus the extended data that came from before erasure coding. And now this block is propagated in the network of the nodes or validators. So every validator is gonna, decode it, reconstruct and verify. And then finally, it can reach consensus on the block. So this is a very base layer architecture of how the Avail actually works. AvailD actually works. And then, okay, base layer stack. As I said, there's also something that we very much focus on. It's consensus, Babe plus Grandpa. So you have data availability, and what Babe is it's a it's a block production engine optimized for liveness. At the same time, we also have Grandpa. This is another consensus algorithm, which is a finality gadget. The reason why we have Babe plus Grandpa is because we wanted to find a balance between data availability and we wanted to find a balance between the liveness, and we wanted to have something for finality as well. So finality not on the blocks, but it's on the chain. And then you can also have like different kinds of, there are other consensus algorithms as well, like Tendermint, but we chose specifically for Babe and Grandpa because of the a good balance between liveness and finality. This is also not related too much for the hackathon, but it's a good thing to know that you have a nominated proof of stake. Generally, there's also something called delegated proof of stake. We chose this mechanism because it is more decentralized, and this allows for the whole chain to not be halted if someone has a large stake in the pool and they get a large reward. So because of this, we chose something called nominated proof of stake. As you can see, nominators can choose not a single validator, but provides a ranked choice of validators. So there's a fair elections of active validators set based on a different kind of election. We support up to 1,000 validators in the active set. Right now, it's probably close to 100, but we can scale it up to 1,000. That's the big thing about the AvailD and the nominated proof of stake. Light client networks. So this is one of the powerful tools that we have in AvailD. What basically light client work is, it's an overlay P2P network on top of the base layer. What it does is that it samples the data from P2P, and then you do not need to download the whole node as I previously said. It just randomly takes in for verification purposes. Okay, what's the Avail ecosystem that will be built on Avail? So you can build anything that is sovereign rollups, validiums, optimistic chain, we call it optimums at this point. You can also do app-specific chains, and then general purpose chains. It's a joke that you can do L4, L5s, but generally L3s are the ones that are coming up too much lately. So yeah, you can build validiums with zk sync. You have Arbitrum stack. You have OP stack, and then you can build sovereign rollups as well. Okay, so this is just a general diagram of like how the validiums and optimistic chains work. There's an L2 validium you see in Ethereum, and then data is being posted to Avail, and then there's an Avail attestation bridge, and then that's posted to Ethereum. For L3 validiums, it's a little bit different. L3 validium basically settle on L2 rollups, and they post the data to Avail, and then Avail basically sends it to Avail attestation bridge, and then it goes to L2 rollups. We want to skip the sovereign rollup just for the sake, because we are low on time. I want to show you some ideas on what you can do with the Avail Explorer, what you can build on it. First, we want to go through the bounties. So bounties are basically, you have a custom app chain. You can build a custom app chain using any rollup SDK. So this means that you have Arbitrum Orbit, you have OP stack, you have Polygon CDK, you have zk sync stack. So you can use any of them. Integrate the AvailD, and once the AvailD is integrated, you can build anything. There's also Stacker SDK, which is very powerful. It's a micro rollup SDK where you launch micro rollups, write your code in JavaScript, and you can build certain games. You can work on some DeFi projects. You can make an NFT project. And then you have MoveVM, Fluent. We're not going to go too much into those, but like Polygon CDK, zk sync, Arbitrum Orbit, or OP stack works really fine. Building with Avail, this is a $3,000 pool price. Here you can use anything to go creative. You can use RIS0 or SP1 to build some custom application on a ZKVM, and then RIS0 comes again. You can also do custom rollups using AvailD. You can make liquid staking for Avail. They're already out there some. And then you can do a P2P address book, which is basically utilizing the Avail Light clients. Another bounty is Best Code Tooling project. This is basically something that can work on the ecosystem or the tooling for Avail. This means that you have an efficiency calculator. You can build some kind of multi-chain or app chain explorers. For example, something which will work with different kind of ecosystems, so the different chains, developer toolkits, dashboards, and then zk bridge auto claim functionality. So anything that that works for the Avail ecosystem and developer tooling, you can build something and you can hit this bounty. Final bounty for $1,000 is testing documentation. This is specifically for ETH builders. We wanted to give a chance for the builders or the devs to run our stack and see what they can build or what are the errors there, and then give us a feedback in a .md file or a GitHub repo. If you're hitting on another project's bounty, you can also include that .md file. Just name it Avail docs feedback, and then add it onto the project and submit it. So there are multiple different documentation, which I'll go through right now, but you have Orbit, OP, ZK Sync, or you have AvailJS SDK, Go, or Rust, and then you can go through those. Any critical value, add feedback on the docs, that's also needed. So anything, you can hit any of these. You don't have to hit all of these, but just one or two. Okay, that was a quick idea on what AvailD is. What I'm gonna do now is I'm gonna show you how the Explorer works. Okay, so this is explorer.avail and then accounts. Here I have a dev wallet account. I have a dev wallet 2. Just simple names. But what basically you're doing is you're submitting data to the DA. How you submit a data to DA, this is a UI, but you can do it through the code base as well. But I'm just going to show you how you can do it through the UI. You go on the developers, you go on extrinsics, and then now here, you see they're using my dev wallet too. It's on the sub wallet, so that is the wallet that Avail uses. You can also use other wallets as well, but just make sure that you're not using any EVM wallet, because Avail is not an EVM chain; it's a substrate chain. So substrate chain generally starts with a number 5 rather than 0x. Or the wallet address is on the substrate chain, sorry. So now we're gonna see how you can utilize, some kind of data availability here. So if you see there are multiple different things that you can look at. We select data availability. There's a create application key. We'll go through what an application key is, but generally you just do a submit data. And we can type anything here. So we'll just type hi, ETH builders. And then you can just submit the transaction. As you see, there's an app ID. So this app ID can be anything, but it's basically something specifically for you. You can use 0 as well, but if you have your own app ID, let's say 2 or 3 or 7, every person can generate their own app ID, and every data that is posted there goes on it, and you can index it, all your data, through just that. You don't have to take all the block space or index all the block space that was submitted before. And now all you do is sign and submit. One sec. Okay, so I submitted it here, and it should go and hit somewhere here. We have this open, or maybe the internet is too bad. Okay, so the data got submitted. You get a notification like that. And after a small second or so, it gets into the recent events. This is basically a network explorer here. So now you can see that this was the dev wallet 2 from sub wallet, and then got posted over here. I can look into more things like what it is or what it does. I can look into the balance that was withdrawn, the data that was submitted through on this data hash, and then I can look for, let's say, extrinsic success. So basically, I can play around multiple things here, but this is what the Explorer looks like. If you want to check some other Explorer, you also have Avail Turing, which is a subscan. So it's a second Explorer similar to the previous one, but it's a little bit looks nicer, or the UI is there. So you can do multiple things over here. Now I want to show you the example that we had. So this is Avail GitHub repo, You see there's an Avail, AvailJS, and then examples, and then we have node examples over here. So I'll just show you. For the Avail examples, you have like TypeScript examples. We also have it in Go. We also have in Rust. All you need to do is install the TS node, and we also have this AvailJS SDK, which is a wrapper of Polkadot SDK. So now, just a general thing that we recently did over here, we submitted a data from the data availability option. So how you do it is you can look into this code here, and here. So this file is basically the code base of how you submit a data. As you can see here, it takes an API over here. It takes an app ID. So you can choose 0 or you can choose your own. And then it takes for the options and the account. So whatever the account you feed into it, you need to provide a mnemonic. The only reason why we're not doing it because it will just show my seed address, my seed phrase. And then this line is probably one of the most important lines. Or these multiple lines, is that it calls in the API and then calls the data availability and then .submit data. This is what we were doing on the UI side. From the UI side, then you sign and send, and everything happens on how we perform this certain action. So this action in the code base looks like this, and probably this transaction call is one of the most important one. You can use anything to post, as I say, like change the hello world to something that has meaning to you, and that's how you are posting data to the AvailD. You can do multiple things as well. For example, here, you wanna create an application ID. So you can create any kind of ID, let's say 89. I can do the same thing through the code base. Create application ID. So this is the code base where you actually create the application ID here. And it does api.txt availability create application. So it's basically calling the function, and it's very easy to just write these lines. You want to make sure that there's some kind of error handling here and then here. So your code base is just working fine. So these are the examples that we have. You can look here for any kind of TypeScript file that you want to look at. So there's a connect, estimating the transaction fee, how much it costs, and then there's a text transaction balance or transaction balance transfer. So these simple, let me just show you the transaction balance here. So here you're looking for the old balance that you had, and this is a transaction call, which is what takes the transaction from your wallet and sends it to different wallet. So the line from 30 to 39 is what does the whole thing. And these are the examples that you can hit to understand what's going on with the different. You can just test it out. And then finally, I want to just go quickly on how you can deploy Arbitrum Orbit with the AvailD. You can deploy multiple things. In our documentation, we have for the OP stack, we have for Arbitrum, and for Validium, we have zkVM for Polygon, and then zkSync or Madara. But you can choose any one of them, and how it generally happens. And because of the bad internet, I would just want to go through this line of codes. You just have a Docker here. Once the Docker is done, you want to git clone the Avail project Nitro contracts, and you want to build it at the end. You want to have a .env file, change those env files, and then copy paste this config for everything. There's a good explanation of what chain ID is, what the challenge period is, what is a stake token or base stake or owner. And then once you deploy it, all you need to do is yarn build forge and then yarn run deploy ETHGlobal. This will just deploy the rollup, and you'll see something like done here. So this is a very, spinning up your own Arbitrum Arbitrum chain with the AvailD. Let's see, once this is done, and for people who are very much familiar with the with the Go or Rust, we also have examples over here. So you can go at Avail Go, and you can look at different, examples directory. So you can look at the Avail Go SDK. You basically need to, go through these things. You need to set up your speed, seed phrase, you need to go for your API, and you need to define your API app ID. And then there's similar thing for the Rust as well. So these are the basic things. We have 5 minutes left. Anyone has any questions so far? No questions? Okay. So again, what you can build with AvailD, I'll just explain you a few more things so that everyone knows for the bounties, because there are a few new people. Bounties that you can make: Arbitrum Orbit or OP Stack, Polygon CDK, ZK Sync, Stacker SDK. You can use any of these to integrate AvailDA and launch your own app chain, building with Avail. So this is basically using RIS0, SP1, or building some kind of liquid staking, or doing a P2P address book. And then bounties for best code tooling. This is something that builds a developer-focused tool, which our developers can use it, or people on the Avail ecosystem, they can use it. This include dashboards, this include multi-chain explorers, this includes like cost calculators or efficient calculators or visualizers. And then finally, the documentation. If people over here want to test out the documentation, you can test out for Orbit, OP, just create a .md file, and then have some of these, put into your GitHub repo, and then also some screenshots out that it was finally running. What kind of feedback you give, that also helps us a lot. Some code was not running, some thing was broken, some links were broken, any kind of these things. These are the major things that you can hit for the bounties. Okay. Got the picture? Okay. Any questions so far? Okay. No questions. Thanks a lot. Hopefully I could explain you. If you have any more questions, you can come to the booth. I'll be there until 1 a.m. or something.